Okay, so today we're going to talk about multiplying matrices. You've already had some background in dimensions and elements of matrices, so you have all the necessary background knowledge that you need for this. The first thing that you need to realize, one of the big rules when it comes to multiplying matrices, is that the dimensions actually do come into play. So, for an example, we have here a 3 by 2 matrix, 3 rows, 3 horizontal rows, 2 vertical columns, so a 3 by 2 matrix. And a 2 by 2 matrix, 2 horizontal rows, 2 vertical columns. Okay, so the main rule when it comes to multiplying matrices is that the columns of the first matrix that you're multiplying have to match the rows of the matrix that you're multiplying it against. So the columns of the first and the rows of the second have to match. If they don't match, then you can't multiply. Okay? These don't multiply the same way that they add and subtract. We don't multiply individual pieces. Okay, so you actually have to have the, again, columns and rows matching. The second part of it, which is why it's very important to know your dimensions, is that these outer numbers, the rows of the first and the columns of the second, actually tell you the size of your answer matrix. Okay, so if I multiply this 3 by 2 and this 2 by 2 matrix together, I can because these inner dimensions match, my answer matrix is going to be a 3 by 2. So 3 rows by 2 columns. Okay, and since we also know about the dimensions and the elements of a matrix, we know, and I'm just going to set this up since I know this is supposed to be a 3 row by 2 column. That's going to be my answer matrix. Okay, if I want to talk about this single element right here of my answer matrix, I know that this is row 1, column 1. That's that element right there. Okay, well that element also tells me exactly what it is that I need to multiply in order to get that single answer. I need to multiply row 1 of the first matrix by column 1 of the second matrix. Okay, now that may sound a little confusing, but I'm going to show you how the setup goes. Okay, so that's row 1 of the first matrix by column 1 of the second matrix. Okay, and in this case, it actually does get multiplied element by element as far as piece to piece, but it gets multiplied in this specific way. So this is row 1 of the first matrix, and this is column 1 of the second matrix. Notice I've put the first piece with the first piece and the second piece with the second piece. Okay, I'm going to multiply both of these pairs and then add their products. So 3 times 2 is 6. 6 times negative 7 is negative 42. I'm going to add those together. 6 and negative 42 is negative 36, and that's the answer for the first element of my answer matrix. That is the product and sum of the first row with the first column. Okay, so we'll do another one. This next piece here is row 1, column 2. So I'm going to multiply, again, row 1 by now column 2. Okay, right? That says row 1, column 2. So I'm going to multiply row 1 by column 2. So I'm going to multiply 3 and 6, again, row 1, by column 2. Again, first piece times first piece, second piece times second piece. And then I'm going to add their products together. 3 times 4 is 12. 6 times 6 is 36. Add them together, I get 48. And that is the second element in my answer matrix. Now obviously I'm going to have to do this 4 more times to get the other two pieces. So let's go ahead and keep going on our example. This is now row 2, column 1. So I'm going to multiply row 2 times column 1. So that's going to be 2, 2 for my second row of my first matrix, and column 1, 2, negative 7. Multiply 4, negative 14, and then add them together. That's negative 10. All right, so let's keep going. This next one has to be row 2, column 2. So again, row 2 by column 2. 2, 2, 4, and 6. Okay, that's 8, and that's 12. Add them together and you get 20. So that's that element right there as far as that answer. We've got two more left that we need to finish. Okay, so the last two, row 3, column 1, row 3, column 2. So again, row 3, column 1, row 3, column 2. So 4, 3, 2, negative 7, and 4, 3, 4, 6. That's 8 and negative 21. Add those together, you get negative 13. 16 and 18. Add those together and you get 34. So my last two answers are negative 13 and 34. Okay, that's just our first example, just to make sure you're seeing how the steps are done. Once you get faster at this and you realize that you're basically going across and down and adding your pairs together, you don't necessarily have to show all of this work. In the meantime, might as well go ahead, set it up, and do it that way. All right, let's try another set of matrices as an example. Okay, so example 2, and let's do something a little bit different. Okay, that's a 3 by 1. Which means whatever I multiply it by, if I'm going to multiply it, that means the rows of my second matrix have to start with a 1. So how about a 1 by 2 matrix? So again, these match. Column of my first with row of my second match. And the outer dimensions tell me that my answer matrix is going to be a 3 by 2. Okay, so I have my setup, and it's the same thing as before. This is just going to be a little bit faster because there's not pairs to multiply anymore. This element is 1, 1, so I need to multiply row 1 times column 1. Okay, well, 2 times negative 5 is negative 10. Row 1, column 2, row 1, column 2. 2 times 9 is 18. Okay, so 2, 1, 2, 2. We're going to just keep filling it in the same way. All right, so row 2, column 1, negative 4 times negative 5 is 20. Negative 4 times 9 is negative 36. Row 3, column 1, 7 times negative 5, and 7 times 9. Okay, same exact method, different size matrix, so we didn't have to do quite as much as far as the adding together. All right, let's try another one. And this is a 1 by 3. Okay. We'll multiply that times a 3 by 1. Okay, so again, we know we can multiply row, or rather column and row match, so inner dimensions match. Outer dimension, well, my answer is just going to be a 1 by 1. That's basically a single element matrix. Okay, well, that means I need to multiply all of row 1 by all of column 1. That means I'm going to have 3 pairs this time to add up. Okay, see, I have 3 elements in each one. So first elements, second elements, third elements. I just need to go ahead and set it up. So just like I did before, 742 times 7, 9, and negative 3. And I'm going to multiply them, and then I'm going to add their products, just like we did in the first one. So 7 times 7 is 49. 4 times 9 is 36. 2 times negative 3 is negative 6. And I need to add all those together. And I think that should be 79. Check my math, make sure. But I think that should be 79. Okay. So, this is how we multiply matrices. And again, it's across and down. Okay? Just across and down. That's how you're always going to multiply across the rows, down the columns. That's why those dimensions have to match. Because we have to make sure we have enough elements to pair up. Okay, so let's try our last example, and then we'll be working on this tomorrow in class. Okay, so we have a 2 by 2 and a 2 by 2. And again, the inner dimensions match. And our outer dimensions tell us what our answer is going to be, and it's going to be a 2 by 2 matrix as well. Okay, so if we try this again without writing down all the work, we'll try it as far as just going across and down. So first elements, 7 times 9, negative 9, is negative 63. Slide across and down. Second element, 5 times 7 is 35. So negative 63 plus 35. 33, I think that's negative 28. So our first answer should be negative 28. Okay, so go to the next one, row 1, column 2. So again, row 1, column 2. First element, 7 times 4 is 28. 5, slide out, cross and down. 5 times 6 is 30. Add those together. Second element should be 58. Okay, go down to the second row. So this would be row 2, column 1. So row 2, column 1. Negative 3 times negative 9 is 27. Slide over, slide down. 6 times 7 is 42. Add those together. And then the last one, row 2, column 2. Again, start with the first elements. Slide over and down. Negative 12 and 36. Positive 24. And that's it. How you multiply matrices. And again, make sure your inner dimensions match, and make sure that you set up your answer matrix to the correct sizes.